In early 2026, the headline screamed that OpenAI killed Sora, its text-to-video star, and the easy conclusion is that AI video failed. But that conclusion is exactly backwards. Here is the precise truth, the spine of this whole story. OpenAI shut down the Sora app, and it is scheduled to shut down the Sora programming interface. But the model itself and the team behind it live on inside OpenAI. The product died. The technology did not. So this is not a failure. It is a shakeout. The video got so good and so expensive to give away that the company which pioneered it handed the crown to its rivals and kept the engine for something bigger. Over the next few minutes, I will show you exactly what happened, then take you under the hood of how AI turns a sentence into a moving, talking scene, and why that is the most expensive trick in all of generative AI. Let us be precise because the details matter. Around the 24th of March, 2026, OpenAI announced it would retire Sora in 2 stages. Stage 1, the consumer app and website on phones and on the web, was discontinued on the 26th of April. That has already happened. Stage 2, the programming interface that let other apps tap Sora, is scheduled to switch off on the 24th of September. Users could export their creations before each cutoff, and account data is deleted afterward. But here is the part the headline skipped. The Sora research team did not disband. OpenAI says it is continuing what it calls world simulation research aimed at robotics. So picture this. One product tile grays out. A second dims with a September clock on it. But a bright spark labeled model peels off and stays lit, drifting toward robots. The surface you could touch is gone. The thing underneath simply moved. So let us kill the myth and find the real reason. The claim that OpenAI killed Sora or that Sora is dead is checkable wrong. Every reputable outlet from major news networks to the specialist tech press reports the same thing. OpenAI retired the product's surfaces and the model lives on. And notice, OpenAI did not publish a single line-item reason for the shutdown. There is no official memo. The richest on-the-record explanation is from Chief Executive Sam Altman, who framed it loosely as resource allocation, concentrating the company's compute into its next generation of work. A real quote, but a general one. So what actually drove it? The reporting converges on one word: economics. According to an investigation by a major business newspaper, running Sora cost roughly $1 million a day because video generation is so computationally demanding, while not bringing in proportional revenue. Treat that figure as reported, not proven, and ignore the louder blogs claiming $15 million a day. The user side agrees. Sora reportedly peaked near 1 million users, then fell below half that, downloads sliding sharply. A money furnace product, with shrinking use, in a company that wanted its compute elsewhere. Here is why this is a shakeout, not a retreat. While OpenAI stepped back from the consumer video product, the rest of the field sprinted ahead. Google's Veo, Runway, and Chinese labs including Qishu's Kling and others like ByteDance all kept pushing. Picture a race where one strong runner steps off the track and the whole field keeps sprinting. AI video did not stall. It went multipolar. And that points at the single most important takeaway in this story. Because video is orders of magnitude more compute expensive than text or images, and I will prove exactly why in a moment, a free or cheap consumer video product is a money furnace. Cost, not capability, became the constraint that reshaped the market. Whoever can subsidize the compute, a company with its own custom chips, or a lab operating at enormous scale, outlasts whoever cannot justify the bill. Keep that idea in your pocket. We will earn it under the hood, and it will explain everything. Before we open the hood, let us be fair about what this technology does in 2026, because it is genuinely impressive. You type a sentence, or hand it an image, and it produces a short clip, from a few seconds up to about a minute, with real motion, camera moves, and increasingly, synchronized audio and dialogue generated right alongside the picture. And frame the next point carefully, because many people are working from an outdated memory. There's an old story that AI video is all melty and physics breaking, glass that will not shatter, limbs that fold the wrong way. That was the 2023 to 24 story. By 2026, the top models produce convincing gravity, fluids, fabric, and motion. Physics realism is largely solved at the frontier. The survivors headline real capabilities now. High-resolution output, longer multi-shot clips that hold together across cuts, and lip-sync across many languages. So we are not asking, can AI make good video? It can. We are asking how and at what cost. So how does it work? Start with the one idea everything else hangs on. A video is not a picture. It is a coherent four-dimensional volume that has to agree with itself over time. 10 seconds at 30 frames a second is 300 separate images, and they cannot be generated independently like a stack of unrelated photos. They have to lock together. A face has to stay the same face from frame to frame. A thrown ball has to keep the same arc. Water has to keep flowing one direction. The hard new dimension video adds over a single image is time, and the standard term for getting it right is temporal coherence, or temporal consistency. So whenever a clip looks real, what you are admiring is hundreds of frames held in agreement. And the foreshadow is, holding them in agreement is exactly what makes this so expensive. The magic and the cost are the same mechanism. Now the pipeline with the real names. Step 1. Compress. Raw video pixels times frames is gigantic, so the model never works on raw pixels directly. A learned encoder, a kind of video autoencoder, squeezes the clip into a much smaller representation called a latent, and crucially it compresses both in space and in time, packing chunks that span several frames at once. All the heavy lifting happens inside this compressed latent space, and only at the very end does a decoder expand the finished latent back out to full pixels. Picture a giant cube of pixels shrinking into a small inner box where the work happens. Step 2. Slice. That latent is cut into spacetime patches, little tiles that each cover a small region across a few frames. These patches are the tokens of video. They are to a video model exactly what word tokens are to a language model, little detailed visual phrases. And because an image is just a one-frame video, the same machinery handles both, the tiles streaming into a transformer like words into a chatbot. Step 3 is the heart of it, and it is beautifully strange. Diffusion. During training, the model is shown real videos with noise progressively added until they are pure static, and it learns to reverse that, to predict and remove the noise. So at generation time, you do something that sounds absurd. You start with a latent full of pure random noise like television static, and then over many denoising steps you progressively scrub the noise away, guided at every step by your text prompt, until a clean latent emerges that decodes into exactly the video you asked for. You are sculpting a scene out of static, one pass at a time. And what does the scrubbing? A transformer. The same backbone that powers a chatbot. But instead of predicting the next word, its job is to look at the noisy spacetime patches and predict the noise to remove. The standard name for this architecture is a diffusion transformer. So a video model is a denoising engine, with one transformer as its denoiser, working on patches, conditioned on your words. So where does temporal coherence actually come from? How do those 300 frames learn to agree? The answer is attention, the same core mechanism inside every modern transformer, but here it reaches across time. Each spacetime patch can look at patches in other frames. This is cross-frame attention, sometimes called spatial temporal attention. That is the mechanism that keeps the same object, the lighting consistent, the motion smooth. Picture glowing threads linking the same ball across every adjacent frame. When those threads are lit, the panels snap into agreement and the motion flows. And here is the experiment that reveals everything. Cut those cross-frame links and the clip drifts. The object starts to wobble between versions of itself. The scene goes melty. So coherence is not a bonus feature bolted on top. It is those attention links doing the work of holding a world together across time. Remember this, because it is also exactly where the bill comes from. Now I can pay off the promise. Why is video orders of magnitude more expensive than text or images? 3 multipliers stack on top of each other. First, sequence length explodes. Video has a huge number of patches, space times time, and the attention mechanism we just met has a cost that grows with the square of the sequence length. Double the patches and you roughly quadruple the attention work. That quadratic growth is the single biggest reason. Second, many denoising steps. Answering a text prompt is roughly one pass through the model. Generating a clip is many passes of that big transformer over all those patches, not one. Third, resolution multiplies the patches again. Going from standard definition up to 4K scales with the pixel area, so it can quadruple the count, and high-end systems often add extra refiner models on top to sharpen the result. Stack those 3, and you get the through line of this entire video. The very same cross-frame attention that makes video coherent is what makes it ruinously expensive. The magic and the cost are one mechanism. There is one more piece, and it is the deepest. Why was physics ever hard for these models? Because they learned statistical regularities from millions of clips. They are not solving the equations of motion. OpenAI's own early report admitted it. Earlier models did not accurately model basic interactions, like glass shattering. A bitten cookie might show no bite mark because the model had not learned cause and effect. The profound point is this. A model that has learned what gravity looks like is not the same as a model that knows the equation for gravity. It has a correlation that resembles physics, not a causal model of it. Those melty failures are history now, the 2023 to 24 frontier, and today's models are far better. But here is the twist that explains the survival story. A model that can predict what the world looks like next, frame after frame, is doing something far bigger than making clips. OpenAI frames these as general-purpose simulators of the physical world models, and that is exactly why the Sora model migrated to robotics instead of dying with the app. To act, a robot must imagine what happens next before it moves, and a next frame predictor is something it can plan against. The clip generator was the detour. The world model is the road. So who is winning the race OpenAI stepped out of? As of 2026, 3 names dominate, each best at something different. Google's Veo is the strongest all-rounder, prized for closely following detailed prompts, with native synchronized audio and high-resolution output. Runway has the deepest creative control pipeline, including a feature that lets you literally paint motion onto a region of the frame, the favorite of careful filmmakers. And Kling, from the Chinese company Qishu, offers high-resolution multi-shot storyboards that hold audio across cuts, with lip sync in many languages, underlining that this is a genuinely global race, not a Western one. But the honest caveat is, there is no single winner. Different models win on different axes, prompt adherence versus creative control versus price versus physics. Leaderboards reshuffle every few months, and other strong Chinese labs are in the mix too. So I name the labs, not a champion, because any ranking will be stale by the time you watch this. And notice why these prices look cheap. Consumer tiers run a few dollars a month because the provider eats the compute. The question was never can it make the clip. It is who can afford to keep serving it. That subsidy is the real moat, and it is exactly the wall Sora's standalone app hit. So practically, what do? If you relied on Sora, the app is already gone, and the programming interface is scheduled to stop in late September. So export anything you still need before deletion. And for new work, move to Google's Veo, available through its assistant and cloud tools, or to Runway or Kling. Now the cost model, because it is genuinely different from a chatbot, and it falls right out of the mechanism we just learned. You do not pay a flat fee per message. You pay by the output, typically by the second a video generated. And because high resolution and longer clips mean more patches and more compute, they cost a multiple of a short standard clip. Flipping to 4K can roughly double or quadruple the rate. As a rough, will-age quickly guide, expect a few cents to around 50 cents per second in 2026. The exact numbers are volatile, so check on the day. But the shape is durable. A meter ticking up per second, that jumps when you raise the resolution. The compute bill made visible to you. Now the honest limits and the real risk. The genuine present-day frontier is long, complex multi-object motion. In a busy, crowded scene, even the best models can briefly lose track, letting two similar objects merge before recovering because, remember, they pattern match rather than reason causally about physics. That is a real current limit, not an outdated one. But the bigger societal issue is this. As generated video becomes hard to tell from real by eye alone, is this real or AI becomes a question you cannot answer by looking. The defenses are real but imperfect. There are content credentials, a standard that attaches signed provenance information to a file, but that metadata is easily stripped by a screenshot or a re-upload. And there are invisible watermarks which survive re-encoding, but only cover content from participating tools, and most tools today are not watermarked. No single defense closes the gap, which is why regulation is stepping in. New disclosure rules, like those in the European Union's AI Act, are moving to make labeling AI-generated media mandatory. The burden is shifting from your eyes to provenance infrastructure and law. Let us do a fast myth check because almost everything you have heard is half wrong. Myth 1: OpenAI killed Sora. No, the app is gone and the interface ends in September, but the model and team continue inside OpenAI for world simulation and robotics. Myth 2: AI video failed. The opposite. It got too good and too expensive to give away while rivals thrive. The shakeout is about economics, not capability. Myth 3: AI cannot do physics, it is all melty. Outdated. That was the 2023 to 24 story. Myth 4: it is basically an image generator stringing a few frames together. No, the hard part is temporal coherence, hundreds of frames held consistent by cross-frame attention, which is exactly why it is so expensive. And Myth 5: OpenAI explained exactly why. It did not. There was no line-item reason, just a general resource allocation quote and press analysis. 5 clean headlines, 5 corrections. So let us land it. The deepest lesson here is that in generative AI, capability is necessary but not sufficient. The thing that decides who stays in the game is who can afford the compute, the ongoing bill, month after month. Sora's retreat is an economics lesson wearing a technology costume. Labs with their own silicon and deep pockets, or with enormous scale, outlast standalone consumer apps, and the capability did not die. It migrated to where it is worth the most, into robots and into rival tools that someone is willing to subsidize. Hold the three-part truth in your head. The Sora app is gone since April. The interface is scheduled to end in September, and the model lives on. The video did not fail. It got too good and too expensive, so the company that pioneered it handed the consumer crown to its rivals and kept the engine for robots. Which leaves us with the two questions that actually matter going forward. Not can AI make video? It can. But who can afford to keep making it? And how will we ever know what is real?